C12, Euler's formula from power series. Now, we have seen Euler's formula already. We derived it earlier, and here it is. E to the I theta equals cosine of theta plus I sine of theta. But very recently, we have seen power series for these functions. For example, e to the x, we have shown, is 1 plus x squared over 2 factorial plus x cubed over 3 factorial, and so on. Nice result. And we have also seen the results for the cosine of x and sine of x. Cosine of x is 1 minus x squared over 2 factorial, and then plus x to the 4th over 4 factorial minus x6 over 6 factorial, and so on. And for the sine of x, we have x minus x cubed over 3 factorial plus x to the 5th over 5 factorial. You may recall that these alternate in signs like this. A plus, minus, plus, minus, plus, minus, plus, minus. And that the cosine is an even function with even powers of x, and the sine is an odd function with odd powers of x. Now, can we arrive at the Euler's formula using these power series? Well, what we're going to do is we're going to let x equal I theta. Then e to the I theta here from the power series will be 1 plus I theta plus I theta squared over 2 factorial plus I theta cubed over 3 factorial plus I theta to the 4th power over 4 factorial. And let's include one more here. I theta to the 5th, the quantity to the 5th power over 5 factorial, dot, dot, dot. Now we use the fact that I is the square root of minus 1. And we'll have 1 plus I theta. And this will be handy now when we square. If we square the I squared, we get minus 1. So this is minus theta squared over 2 factorial. Now here there'll be another factor of I theta. So this will be then minus I theta cubed over 3 factorial. Now for another factor of I theta, the I squared will give a minus 1, which will cancel that minus 1, and we'll get theta to the 4th power over 4 factorial. Notice that the odd ones have an I factor and the even ones do not. So when I theta hits this, we'll have I theta to the 5th over 5 factorial, and so on. So now what we're going to do is we're going to group the real and the imaginary parts. So the real parts would be the even ones. 1 minus theta squared over 2 factorial. You probably already see it's going to come out. So this is the real part, and then for the imaginary part, we'll start with theta. Then the next one's minus theta cubed over 3 factorial. Then theta to the 5th power over 5 factorial, like this. Now you can see that 1 minus theta squared over 2 factorial plus theta 4 through 4 factorial, that is giving us the cosine. So this is going to be the cosine of theta. Meanwhile, over here, we're going to have theta, which is the x in this formula, then minus the variable cubed over 3 factorial, then plus the variable of the 5th over 5 factorial. So this is the sine of theta. And we have succeeded in arriving at Euler's formula another way. It's always good to see things derived more than one way. Very elegant. Everything fits together.